Hello, in this video we'll do exercise 17, page 15. Find the GCD of each pairs of numbers in each of the following cases. Here we have to think. We have 17 and 34. We think first, are they consecutive? No. If no, we think, is there a relation between them? This means the smallest number 17 times anything equal to 34? Yes, it is 17 times 2 is equal to 34. So there is a relation between them. In this case, we know that 17 is the divisor of 34. Look, 17 is here. So 17 is the divisor of 34. 17 is a divisor of 34. So the GCD between them is what? The GCD of 17 and 34 is the divisor, which is 17. Here we have 42 and 43. We think first, are they consecutive? Yes, they are consecutive. So the GCD is what? We say 42 and 43 are consecutive numbers. So the GCD is equal to 1. Now we have 16 and 48. We think first, are they consecutive? No. Is there a relation between them? It means 16 times something equal to 48. Yes, it is 16 times 3 equals to 48. So what can we say about 16? 16 is a divisor of 48. It's a divisor of 48. In this case, the GCD is equal to what? It is equal to the divisor. What is the divisor? It is 16. Now part B. Among the following pairs of natural numbers, indicate those formed by relatively prime numbers. Here how to think. We think it is different from part A. Pay attention. Here we think the question is relatively prime, about relatively prime. We think, are they consecutive? If yes, so yes. If no, we think, do they have a common divisor? If we can't see directly that they have a common divisor or not, we have to find the GCD. So look, we have 9 and 16. They are not consecutive. First, they are not consecutive. Can we see that they have a common divisor? We cannot. So let's find the GCD. We know that 9 is equal to 3 to the power 2. We know it. And 16 is equal to 4 to the power 2. Don't we know it? Yes, we know it. So here the GCD between them is equal to what? Look, do they have a common factors? No, they don't have a common factors. So here the GCD of 9 and 16 is equal to 1 because no comma between them, no common factor. Now 21 and 25. Are they consecutive? The first question, no. Can we say see directly they have a common divisor? No. So what we do? Look, we know that 21 is equal to 7 times 3. And we know that 25 is equal to 5 to the power 2. We can find them directly without the tree method because they are easy numbers. So now they have a common divisor. No, here we didn't answer the question. Are they relatively prime? Yes, they are relatively prime. So when the GCD is equal to 1, so we say 9 and 16. So 9 and 16 are relatively prime. Now here, do they have a common factor? No, so the GCD of 21 and 25 is equal to 1. So when the GCD is equal to 1, so they are relatively prime. So 21 and 25 are relatively prime. Now here, 30 and 48, we think first, are they consecutive? No. They have a common divisor. Before we find the GCD, they have a common divisor. Can't you see that they have 2 as common divisor? We have here 0 in one's digit and here 8 in one's digit. So 30 and 48 are divisible by 2. So 30 and 48 are not relatively prime because they have a common divisor, which is 2. So 30 and 48 are not relatively prime because they have 2 as common divisor. Now let's look at 48 and 51. Are they consecutive? No, they are not consecutive. Before we find the GCD, can we see if they have a common divisor? Sure, it is not 2. They don't have 2 as common divisor. But if we add the digits here, 4 plus 8, we get 12. So this number is divisible by 3 because 12 is multiple of 3. And if we add 5 and 1, we get 6. And 6 is multiple of 3. So this number is also divisible by 3. So they have 3 as common divisor. So they are not relatively prime. So we say 48 and 51 are not relatively prime because they have 3 as common divisor. Now part C, correct the mistake in each of the following cases. So we have a mistake and we have to correct it. GCD of 16 and 32 is equal to 32. Look, we know that 16 times 2 is equal to 32. So what is the divisor? It is 16 or 32? Sure, it is 16. So the GCD will be the divisor, which is 16. So the GCD here is equal to 16. So here, GCD of 16 and 24 is equal to 4. Sure not, because we have a bigger divisor than 4, which is 8. But if we have to correct the mistake, we know that 4 times 4 is equal to 16. So in this case, the GCD between 4 and 16 is equal to 4 because 4 is the divisor. So we can correct the mistake like this. GCD of 4 and 16 is equal to 4. Now GCD of 27 and 33 is equal to 1. No, they have 3 as common divisor. So if we have to correct the mistake, let's write two consecutive numbers because the GCD of two consecutive numbers is equal to 1. We can write that GCD of 27 and 28, for example, is equal to 1. And thank you.